Hello everyone. In today's video I'd like to show you a demo of the Azure Device Provisioning Service. In this demo I will be setting up a single physical device using Individual Enrollment and an MX Chip IoT Dev Kit device. I will cover the steps to set up the enrollment in the Device Provisioning Service as well as write the device code to register the device with the DPS. Let's get started. The first thing we need to do is go into the Azure portal and create our resource instances for the Device Provisioning Service and IoT Hub. So you can see here I'm in my resource group, Device Provisioning Service, and I'd like to create an instance of the Device Provisioning Service. So I can click Add here, type in Device Provisioning Service, and select IoT Hub Device Provisioning Service. I'll give it a name, a subscription. It automatically puts it in the resource group I'm in, and then a location, which also defaults to Central, which is what my resource group is in. Click Create to create it, and it will validate and create the resource. Once it's created, we can go back into our resource group, and you can see now that our Device Provisioning Service instance is available. We also need to create an IoT Hub instance, so let's just click Add again, type in IoT Hub, and select IoT Hub here, click Create to go through the process. Again, it's going to ask you for the subscription in the resource group. I'll want to change the region to be in the same region that my Device Provisioning Service instance is, and then the name. I'll click Next to go to networking. We'll just leave this the same. When I go to the size and scale, I will choose the free tier, but you can choose whatever tier makes sense for you. And then click Review and Create. Once this is done, we can again return to our resource group, and you can see now that our IoT Hub instance is available. The next step now is to configure our Device Provisioning Service instance. So if I click on this and go into it, one of the things I have to do is I have to link the IoT Hub instance that we just created to this instance of the Device Provisioning Service. In order to do that, I click on Linked IoT Hubs here on the left, and it will show you a list of the IoT Hubs that are linked to this instance of the Device Provisioning Service. Since we don't have any, I come up here and I can click Add, and it will open up a pane on the right here to select the IoT Hubs that I have available to link to this. So it's going off of the description, the subscription I have, and when I drop down the IoT Hubs, you can see here it's got my test IoT Hub 1234, which we created earlier. So when I select that, the next thing here that it's going to ask for is the access policy. And that's the credentials and permissions that are needed to establish this link. So when I drop this down, since I only have IoT Hub owner, I'm going to select that. And you can see here, it gives additional information about the status, the pricing tier, and where it's located. Once this is all selected, you can click Save to actually save the link, and it will go and do the linking to the Device Provisioning Service. And now you can see that it says it linked it successfully. So when I hit refresh, there you can see that now I have a linked IoT Hub to this Device Provisioning Service. At this point, the instance of Device Provisioning Service is configured, and we're ready to move to the next step. The next step is to prepare some code that will be uploaded to our IoT device. As you can see, I'm using the MX Chip Dev Kit AZ3166 device, and I have already loaded the latest firmware on it and configured it to access my wireless network. I will be using the sample code from the Azure IoT Workbench Getting Started examples, which can be downloaded at the URL displayed. Once we've downloaded the sample code, we can now load it up in Visual Studio Code and begin to edit it. So you can see here, I have the INO file open, and we'll need a few things here. For the first things we'll need to do is we'll need to fill in the global device endpoint and the ID scope variables for the device provisioning service instance that we have. So if I go back to the portal, and in my resource group, I can open up the device provisioning service instance that I have, and the global device endpoint I have is right here, so I can copy that to the clipboard, go back to my code and enter that in right there. And then the ID scope is right here, so I want to copy that and also paste that in there and then save the file. Okay, so once we have the global device endpoint and the ID scope defined in our code, we also want to define our registration ID for the individual enrollment that we're going to be creating in the device provisioning service instance. So we'll call this test device 1. And then once we have that and we save that, we can upload that to our device. And once this is done, the next thing we need to do is we need to create a X509 certificate that we can load when we create that individual enrollment. And we'll do that once the code is uploaded properly to the device. So once we have this uploaded here now in Visual Studio Code, we need to create that certificate. So if I hit F1 and go to the configure device settings, I need to create a unique device secret. So when I click on that, it gives me this long string of numbers and letters. And once I have that, I hit enter, and the system now expects me to go into configuration mode for the device. Which by pressing the A button and the reset does that. And then you'll notice in VS Code, here, let me get this out of the way, that it says successfully configured device, unique device string. So we've configured that with the device, and now what we need to do is we need to create the certificate for it. And in order to do that, I can go F1 and open a new external terminal. And what that will do is that will bring me to where my code is. And there's, if I do a directory under the tools, under the tool directory, there's an executable called DPS CertGen, which generates that certificate for you. So I can call that, and then it's going to ask me the name of my project. So in my case, I want to say .build dev kit DPS, and then it's going to ask me for the UDS that we just saved in our clipboard. So I'm going to type that in, and then it's going to ask me what my registration ID is for the device for the enrollment. So we called it test device 01. So we'll type that in, and then as you can see, it created that certificate file. So now if I do a directory, you can see here it's called testdevice01.pem. So it created that file. So the next thing to do is to go back into our device provisioning service instance, and under manage enrollments, we'll add an individual enrollment, and you do that by clicking on that add button. And now it's going to ask you what mechanism to what attestation mechanism you want. So you can do X509, TPM, or symmetric key. So we'll leave it at X509. It's going to ask you for the certificate file. So in our case, it's this testdevice01.pem. The IoT Hub device ID, so you can leave this blank if you want it to be the same name, or you can type in something different. So we're just going to type in testdevice01. We're not dealing with an edge device, and the how you want to assign devices to hubs, as well as the hub that we want to work with, which is my test IoT Hub 1234. They're auto-populated, so we can leave those as they are. Same thing with reprovisioning. Now, and then finally, the initial device twin state gives you something to start out with. I want to add something here. Current color. So what we're going to be doing is we're going to be modifying the code so that it lights up the LED, and I want that to be controlled by the device twins. So we're going to put a desired property called current color in here. And then finally, whether enable entry tells it whether or not it's enabled right away or not. So I'm going to hit save. And now you can see that it added the enrollment. And now if I go back to my device and reset it or reboot it, you should see that it should try to connect to the Wi-Fi and register itself with the Device Provisioning Service. And there you can see it says DPS connected, which means that it actually is working. So if we actually go to our Device Provisioning Service and go back into this individual enrollment, you can see now that the registration status says it's assigned and what hub it's assigned to and what the device ID is. So the registration status here tells me that it was successful. I can also check by looking at in our IoT Hub under IoT Devices. You can see here now that test device 01 is there, it's enabled. And if I actually go into that and look at the device twin, you can see here that my desired property is there. Okay, so now that we have it connected to the device provisioning service, what I want to do now is I want to modify the code so that we can control one of the LEDs through the device twins. So back in VS Code here, what I can do is I'm going to add some variables that help me do that. So I'm adding a variable called current color, which will read from the device twin when you make a change. And then I have a color table here that I can use to determine what color to set it to. Now you'll notice that our RGB LED is undefined, so what I need to do is I need to add an include file. And I'm going to add it called RGB LED, and then that will light up and recognize that. I also want to comment this out. So the send confirmation callback in this example code actually blinks the LED that I want to control myself whenever a message comes back. So we're going to comment that out so it doesn't do that. And now in the device twin callback, I want to do something a little bit different here. So the way this works is that when the device twin is changed, it comes in here, it will fire this method and it will read and parse that twin message. So if I actually look at this and go to this definition, you can see that this parse twin message will take what you send it and parse out the JSON value, and then do a few things and say what it's updated to. So I want to do my own thing here. So what I'm going to do is I'm going to comment out that parse twin message, and I'm going to add some code that I have here myself. Okay, and this code also requires another include file here for parsing the JSON. So what I'm actually doing here is now the first thing I do is I just spit something to the serial monitor, and then I'm parsing out this root value and then making sure that it's of type JSON object, and then I get it, and then I'm looking for either the word desired dot current color or just current color, and what I'm doing here is I'm pulling out that value into the current color variable and then spitting it out to the serial monitor. So this is going to set the current color value and then show what it's been changed to if in the serial monitor. And then once it does that, I also need to then actually set the variable or set the LED. So I basically have a bunch of if checks for the different colors. So if it's red, it'll set it to red. If it's green, it sets it to green, blue, and so on and so forth. Otherwise, it'll turn it off if it's one of the if it's a color that it doesn't recognize. And then finally, so we don't need to do anything with the setup. The setup is exactly how it should be. And then with the loop, I do want to change some things here. I don't want it to send temperature data like the example does, but I do want it to check the MQTT client every time it loops through here. So I'll leave that uncommented. And then I don't want it to delay 10 milliseconds. I want it to delay every 1 second. So I want this loop to run every second. So now that we have our code edited, we can upload it to the device. And now you can see that it's actually going up to the device and being uploaded. And once it's done, it's going to try to reconnect itself to the Wi-Fi and then to the device provisioning service. Now you'll notice that it failed, and that makes sense because we did modify the code, but we did not regenerate the certificate for that individual enrollment. So therefore, it's not going to match, and that's why it failed. So what we need to do then is we need to, in VS Code, we need to create the new unique device secret. And again, you can see here that it said successfully configured the device secret. And now what I can do is I can go back into, so I can run this again. Add in my UDS. Test device 01 was what our registration ID was called. And then it generated a new one. So we can go back into the portal. Go back into our device provisioning service instance and get to that enrollment. Now, once we go into the enrollment, we need to delete this registration. Otherwise, it's just going to keep what it has. and then delete the current certificate, pick the new one that we had. Make sure everything else is the same, and then hit save. And once that is done, we can go back into, we can go to our device and hit reset. And it should reconnect to the device provisioning service again. And there you see it's connected. And now you can see, it takes a few seconds, but you can see now that the LED here is yellow. Now, if you watch the serial monitor, let's see if I can do this, and I'll bring up, let's make this window a little smaller here. So if I bring up the device through IoT Hub, so there you can see it. And if we go to the device twin, you can see now that it says yellow, but I can change this here for the device. And when I do this, let's just make it red. When I hit save, you'll notice that it's going to change this, update the version, and then you're going to see a message in the serial monitor that it received that change, and then the code should update the LED to red. So there you can see last updated version 2, and then now you can see that the current color is red in the serial monitor, and there you can see the LED has changed to red. I hope the demo in this video was helpful in understanding how to use the Azure Device Provisioning Service. If you have comments, leave them in the comments section below. If you like this video, please click the like button, and for more videos like this, click the subscribe button. Thanks for watching.